acting on the database, you're wondering who's doing what, whether or not a scan is started or finished, you can be logging the event information when the scans start and finish and tell real time what the status is and what people are working on. So then we have fat loots. And for loot, loot is mostly used by Metasploit Express and the more commercial products, but we have it available to us as well. So with the loot, it's basically anything that you have acquired from the host that you find to be valuable. We don't store the content necessarily in the database, but we have the host service information, the type of the stuff that we have acquired. And then the path variable says where to find that. So if you have a shared storage area that's secure where you put all of the goodies that you required, for instance, maybe cracked password and stuff like that, you put the path to that. The data has some extended information about what that information is. The content type says exactly what it is. And then you have a name just to keep track of it. Clients are what we're using for Beef. For all of the web stuff, we keep track of a couple different pieces of information as we have hosts come in. This information is also stored by things like DB Autopwn and any of the other web parts that come in. We get information about the host, the full user agent string, but we also get some parsed out user agent information, like the name and the version. So if you are looking for maybe performing some further testing on an older version of IE, this would become very handy. You can just go and query all of our hosts that are running an older version of IE and then send them a little file to test out. For users, the user information isn't always directly visible, but we can view it. It is created automatically. There's a plugin that will allow you to get to it from the console, but through XML-RPC we can get to it regardless. So we can store data here even though Metasploit itself is not storing data here. As we go through and we acquire some credentials, we have the ability to log all of that here for action in the future. This is especially valuable if you're doing things, for instance, you're wanting to do some pass the hash or things like that. We've got all of the tokens here and things like that that we can store to be able to further gain access on the network. So I have a little bit more time, so I'm going to actually go into some of the code itself at this point. The code for a lot of this is fairly simple. I'm using Python because Python has an XML-RPC module that facilitates working with this stuff very well. So I'm going to start off by looking at just the host info stuff. So for host info, all of this stuff up top is just parsing options. So basically, from the options that get passed in, we need a server URL that we're going to connect to. We need the username and the password to authenticate to XML-RPC. So for XML-RPC, there's a couple pieces of information that are really good to know when you're writing applications. The first is after you authenticate, you're given a token. That token is good for 15 minutes, and any subsequent requests that you make, you pass in that token. After 15 minutes, then you won't get anything back except for errors from Metasploit. So you have to make sure you're renewing your tokens every 15 minutes. I occasionally, when I've done stuff because I've had slowness and things like that, ended up with tokens appearing to be expiring before the 15-minute mark. So typically when I'm writing stuff, I renew my tokens at the 10-minute point. So right here, we are opening up RPC connection into the Metasploit server. Then we call the auth.login function. And the auth.login function, we pass our username and password, we get back our token. If the result from that, pretty much all of the calls come back with a result if it is a thing that you're asking it to do. If you're asking for data, you don't get a result back, you just get data back. So since we have a result back, we know that we were successful, and then we take the token from that and we're going to use that for the rest of the stuff that we do. After that, we define our workspace. If we're looking at a specific workspace, then we will go ahead and assign that to our extra options. And after that, we just start asking for stuff and printing it out. So the get host says get all of the hosts that we specified on the command line. And then after that, it's just a matter of enumerating through and printing stuff out. So for services, we just drop into a loop and print out each piece of the object at a time. So it's not overly complicated. Probably as you're going through, there's not a lot of documentation on exactly what's being returned right now. There's a wiki page in Metasploit, which I'm going to start updating as soon as this makes it into the trunk with what information is returned back from which pieces, so that there's some good reference for that. As far as the other functions go, for XML RPC and the documentation subdirectory, there's an XML RPC.txt that has a list of what you pass to each one of the functions. So, sorry, this is a little bit a pain to read, but basically we're just iterating through stuff and printing out each piece of the object in order. So where this is especially valuable is if you want to perform further actions on stuff that you've done. So for decom.python, which I wanted to do something where I could test and make sure it's working, and decom always works on XP service pack 0 boxes just about, which is the awesome box that I've got up here. So for testing, it makes it really easy. So basically to only send it to hosts that have the right stuff listening, we specify our information about where to connect to up here. We're connecting to our local host, logging in, and then after that, we are going to get a list of all of our services that are running on 139 for TCP. And so from there, we can make sure that as we're calling stuff, we're only calling hosts that are relevant. So from there, if you're going to be doing stuff like this, a lot of the time you're better off using multi-handler than you are using the default handler for exploits. And for people who may not be familiar with multi-handler, what it does is it acts as the handler for the exploits themselves. So you can have a whole bunch of different reverse TCP connections coming back in to the same place, and you don't have to worry about any sort of conflicts with ports or anything like that. So I do two things here. First, I start off by going ahead and running multi-handler so that any connections that come back to the multi-handler instead of the payload handler for the exploit itself. Then I pull the list of services, and for each service that's listening on port 139, I run callsploit on it, which just does a basic execute for our exploit using our authentication token and the, in this case, the Windows DCE RPC MS03 026 DCOM vulnerability. For this, we just have to specify our IP address, the IP address of the remote host that we passed in, the payload we want to use, our IP, and then one of the important things is the disable payload handler, which is what actually turns off the payload handler. This will also increase the speed as stuff goes out because your exploit won't be waiting for something to connect back to it. It will send the goodness out and then wait for it to connect back to the multi-handler. So for here, we have a couple things that are running on Microsoft ports. So we should be able to just come over here, run our decom.py, and it pulled the hosts that are in the database, and now we have remotely called the exploit, gotten back our host, and we have all of the goodness that we may want. So with something like this, and with psexec, one of the nice pieces about it is, say you have gotten one host, you have captured some credentials, and you want to look at what other hosts in the network you may be able to get additional tokens on for pass the hash. With psexec, you can go through, you can put in the credentials that you have right now, start scanning the network, and then use Meterpreter's auto-run capabilities to do further information gathering as you're going through the network. So you may want to do something along the lines of when enum, which as it connects into the host, it runs your shell, comes back, and will pretty much profile everything about the host. As this goes through, you can start looking and further elevating privileges using the information from there, but you'll also get a lot better network map as you start going through with that. Now the plus side is because we have already done an Nmap scan and we know which hosts are listening on Windows ports, we're only going to be sending this stuff to Windows hosts. So if you have some sort of network anomaly-based detection that's looking for traffic on Microsoft ports for Linux boxes or whatever, you're not going to trip that. And also, you make sure that if you're limiting your scope, you're only doing things that apply directly to your scope. So one of the scripts that might make sense for the future, if people are interested in making sure that all of the hosts that they've scanned, the information that they may do things that are actionable on is only limited to certain ranges, is go through, look at what all's there, and then delete everything out of the database before they start going that is outside of their scope. So as far as the Nsploit goes, right now I just have it adding ports, but one of the things that would be really cool is for the Nmap developers, as they start writing checks for extended information about shares and all of the other goodness that's involved, to be able to drop notes through this, to be able to, as you're scanning, log every piece of information that shows up as the script portion for Nmap. So I'm going to look a little bit with you at the Nmap stuff. So the latest version of Nsploit will run a lot more places. It has, last year when I released it, it required an additional Lua module. Now it is straight XML RPC. It requires nothing else, so it should run on iPhones, it should run on any sort of device that you can put Nmap on, and has the Lua stuff installed for scripting. So for this, when you drop it in, you've got two separate directories. You've got your NSElib and you've got your scripts. So my Nmap is installed in user local, and so if you look in user local share Nmap, you'll see that there's two directories which correspond. The NSElib, which is all of the core libraries that the other scripts use, and then the scripts themselves. And so pretty much you copy everything from NSElib and the Nsploit distribution over to NSElib, and everything from scripts to scripts. And so when we look in scripts, we have MSF add port. So basically for this, we have two separate pieces. The port rule says when this should fire. And so we've said that the port rules should fire whenever it finds a port that is in the open state. And the action when it does that is we start off by initializing the Nsploit stuff. And for Nsploit, you have a file that is in your home directory with all of the information about where to connect to. Otherwise, you have to pass a whole lot of information to Nmap, and it's not a lot of fun. So the config file ends up being a lot easier. So the MSF init pulls your values in. And then for this, we specify our options for things that Nmap has found for us. Our host IP, our port number, protocols, blah, blah, blah. And then from there, we can just issue an MSF call directly to the XML RPC API function. It goes ahead and takes care of the token handling for you. The reason for that is Nmap has some storage area where we can deal with that a lot easier than any of the individual scripts can handle it. So I take care of all of that in the Nsploit library. So pretty much all you have to pass to this one is the function you want to call and the options. So this goes out, connects to Metasploit database, adds the data, and comes back. And a lot of this stuff has the ability to run in parallel. So I'm getting close to being to the end. So thanks very much. I've had a great time here. Thanks to all these people who've helped me get stuff going. And also especially to the people who've written the tools that I'm leveraging, especially the Metasploit guys, Theodore and Wade Alcorn, who've helped me a lot with stuff. So thank you guys very much. Here's my contact information. If you're interested in more stuff, let me know. Hit up my blog probably Monday evening, and I'll have all the source code, and I'll try to get the slides there.